Now let's solve some problem using method 2, which is NCR method. We're going to find the binomial expansion of some problems using NCR method. We are already familiar with the NCR method, which is in this shape. This blue is my R. This yellow n is my this power. Whatever power you have for the n, you just plug in there. And these are my R. So we call NCR method. In short, we can write that a plus b to the whole n equals to summation of NCR times a to the n minus r times b to the r, where r starts from 0 up to n, which means that the time when r equals to n, then the process will be completed. So this is the short form of a plus b to the whole n for the NCR method. If the value of r equals to 0 here, if we have n 0, it equals to 1. But in case if r equals to n, remember this n is actually my r. If the number of r equals to the number of n, which is the power of the binomial expansion, then it equals to 1. So in both cases we get 1. So let's go to solve some problems now using NCR method. We're going to start with the problem number 4, because look, we have covered the first 3 problems for method 1. Now we're going to start from the 4th problem, which is for method 2. It is NCR method. If the question asks that find the binomial expansion of 1 plus x to the whole cubed using NCR method. Look, sometimes they may ask that find the binomial series. Sometimes they may ask that find the binomial expansion. Binomial series means to expand this term. Therefore, we can call it binomial expansion. Now, this time I'm using NCR method. NCR is n choose r. Let's use NCR method. The given expression is 1 plus x to the whole cubed. This is the NCR method. We have 3 0 into 1 to the 3 times x to the 0 plus 3 1 into 1 to the 2 times x to the 1 plus 3 2 into 1 to the 1 times x to the 2 plus 3 3 times 1 to the 0 times x to the 3. Just apply the NCR method. For the n, we plugged 3 because my n is 3 here. So put 3 all the way for all the yellow n's. Here, 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 and here. And then the value of r. This is the value of r, which starts from 0 and then 1 and then 2 and then 3. So the time when this 3, which is n, equals to r, then you have to stop the process. You have completed the NCR process here now. You don't need to add more terms. That's what we do. The r is in ascending order on the right side. It increases by 1, first 0 and then 1 and then 2 and then 3. Similarly, in the last term, the power of 1 is 0. If you get the power of 1 equals to 0, which is my first term, it means that you should stop now. Simplify it, which equals to 1 times 1 to the 3 times x to the 0 plus 3 times 1 to the 2 times x to the 1 plus 3 times 1 to the 1 times x to the 2 plus 1 times 1 to the 0 times x to the 3. Now we know that if r equals to 0, then the expression for the first coefficient will be 1. So we have the product of 1 with the first term. Similarly, if n equals to r, then it equals to 1. I just told you that look, if r equals to 1, no matter whatever value you have for the n, which is the power, it doesn't matter. But if r is 0, n 0 equals to 1. Similarly, if n, which is the power, equals to r, then it equals to 1. Remember, these are actually the expression to find the coefficient. This is for the coefficient. So the coefficient for the first term will be 1, and coefficient for the last term will be also 1. Therefore, 3 0 is 1 and 3 3 is 1. We can see here that for the first term, we're going to start with the maximum power, which is actually the n. It is 3, so I'm going to start with the 3, and then it goes in descending order by decreasing 1. In the second term, we have 1 to the 2. In the third term, we have 1 to the 1. In the last term, we have 1 to the 0. So 3, 2, 1, and 0. When you come from the left side, it goes in ascending order from the left side, but from the right, it goes in descending order. Similarly, when you look to the second term, it starts from 0 and then 1 and then 2 and then 3. which means that it goes in ascending order from the right side. But from the left, it goes in descending order. Look, we are already familiar that whatever value you have for the n, you just put it here, take its product with the second term, and do the same thing on the other side. Here we can take a little bit help from the symmetric method. For the first term, we have the product of 1. For the last term, we have the product of 1. So there is a symmetry. Similarly, for this, we have the product of 3. Here we have the product of 3. Again, there is a symmetry, which implies that 1 plus x to the whole cubed equals to 1 plus 3x plus 3x squared plus x cubed. Because x to the 0 is 1 and 1 to the 3 is 1, so 1 times 1 times 1 is 1. Similarly, x to the 1 is x, 1 to the 2 is 1, so 3 times 1 times x is 3x. 1 to the 1 is 1, so 3 times 1 times x squared is 3x squared. 1 to the 0 is 1, so 1 times x cubed is x cubed. There we got the final answer. This is the final binomial expansion of 1 plus x to the whole cubed using NCR method.